I spent a long time thinking that I was too cool to fall for the AI hype or too cool to kind of get involved with the AI research. And then I kind of started following the folks who are doing AI research and are building stuff with AI. And I kind of realized that they're kind of cool and the stuff that they're doing is kind of cool. And it was one of those things where I was like, I could either just let myself get left behind by this and just know nothing about it, continue being the guy who's just too cool to learn about AI, or I could at least kind of dip my toes into it. And there were actually a couple of I guess more minor reasons why I didn't kind of get involved with learning about AI. One of the biggest, just kind of paramount reasons is that it's math and I suck at math. I'm horrible at math. I failed stats 1.5 times. I very nearly failed it again in college. I did very, very badly in discrete mathematics. I did very, very badly in just about every math class that I ever took. Um, but over the last couple of weeks, I've kind of grappled with it and realized that I don't want to be left behind by this, both for monetary reasons and just because this is kind of where the world is going. And you can either kind of keep up and be part of it and build cool stuff with it, or you can continue trying to be the cool guy who doesn't get involved with it and just, leave it alone and probably miss out on a lot of cool opportunities and money and different things like that. Also, from the math perspective, I'm like, okay, math is just kind of part of the entire world, and continuing to be bad at it isn't great. I need to kind of shore up that weakness in myself. So I'm starting kind of a new focus on AI and machine learning study sessions. Essentially, what I'm going to be doing is spending a couple hours a day studying different AI topics in different ways. So I'm going to be studying books, videos, kind of getting better at math and doing so a little bit more publicly, and kind of doing rant videos and rant blogs about it, kind of talking about my learning. So the primary way that you can kind of follow this is on my blog, blog.valhallaresearch.net. I'll leave a link to it everywhere. But I'll be posting these study sessions essentially when I've actually learned something worth talking about. I'll be doing the studying every day, but I won't be putting the actual blogs up every day because that would kind of get pointless. A lot of times I'm going to be kind of stuck on different topics, especially mathematical topics. I've already kind of reached a couple of those areas. But let's kind of talk about the first session. So the first thing that I did, I don't actually have the book next to me. I think, yeah, I do. I picked up this book from Books A Million, Practical Deep Learning by Ronald T. Newsel. I'll leave an affiliate link down in the description if you kind of want to follow along. It uses Python, which I'm not thrilled with. I'll kind of talk about that a little bit more in a bit. But it does use Python, is what it is. It's at least going to be readable. And I will say I've made it about 80 pages into the book. It's pretty thick. It's like a 400-page book. So I've made it about 20% of the way through the book. A couple of the things that I don't love about the book, one, Python is what it is. I would love for the book to be in Rust, but Rust is a newer language, and Python still is kind of the language that is go-to for machine learning stuff for a variety of different reasons. One of the other things is it doesn't focus that much on the math. It kind of gives you enough to Google, but it doesn't really go in depth into it, which is fine because they make math textbooks for that, and they make 3 Blue 1 Brown the channel for mathematical stuff. There's tons of different resources for me to learn math, so I don't really need all of the books to be about it. The author explains technical stuff very, very well. They get into the weeds with Python syntax a little bit too much, but it's built for people who don't know that much about programming and want to pick up deep learning. So I'm kind of okay with skipping, I skipped 2 whole chapters on Python syntax. If you're familiar with Python, you're going to be able to skip 2 chapters, but there's still a ton of stuff in there that is specific to deep learning, specific to kind of the high level stuff. Skipping ahead past this blog, it does get more into the high level concepts of the math, but it doesn't really break down the linear algebra, at least at the point that I'm at. So a couple of different things that I've learned thus far. One, it was very interesting to me learning that essentially a lot of this, or at least probably most of this, is arrays. It's literally vectors and matrices and different things like that. It's all arrays. Now, obviously, it's way more complicated than that. You're basically transforming complex data into arrays in order to make assumptions off of that and training things on that and all of that. but it is functionally all just operations on arrays, which is really, really good for folks who are programmers because we work with arrays all the time. We're familiar with arrays. Now, these are multi-dimensional arrays. These are 3, 4, 8-dimensional arrays. So things get very, very complex and very heavy, which is why you've got libraries like NumPy to kind of deal with that stuff. But yeah, it's a lot of array stuff. And apparently linear algebra is essentially just operations on arrays and, different ways to kind of manipulate arrays. That was interesting. Now, one of the things that I learned that was mind-boggling to me, Python lists, the reason why Python lists are so slow is that, in a given programming language, I guess I can actually visualize this with Excalidraw. So this was from the last video I just recorded. And a normal everyday programming language, you've got contiguous blocks of memory, right, that make up an array. So these are contiguous blocks of memory. If I can properly draw with this. So these are each, individual items within an array. So you've got you've got 0. You've got 1, you've got 2, you've got 3, etc. All of this is all in one memory block. So this is at 0x01, 0x08, basically based on the size of the individual item. If it's like an 8-byte, piece of information, then, these are going to be laid out in 8-byte chunks, all contiguously. That's how normal arrays are. That's how C arrays are. That's how Rust arrays are, I believe. That's how normal arrays are. Python, for some reason, instead of doing this, they've got a different structure, which is bonkers to me. They've got a structure that is more akin to a linked list. So you've got 0, which points at 1 as the next item, and 1 can be located anywhere. 1 points at 2, which can be located again anywhere. 2 points at 3, which again can be located anywhere in memory. And you have to follow these pointers in order to get to each individual item. Now here's where this matters. If I want to jump to item number 3 in the array, all I've got to do is get the base location of item 0, which is just going to be a pointer to the beginning of the array, and I multiply the size of the individual item. So let's just say 8. I multiply that by however many, spaces I need to jump, in order to get to item number 3. It's a very, very quick math calculation here in order to jump to item number 3. If I wanted to jump to item number 3 in a Python list, I would have to start at item 0, follow the pointer in memory to item number 1, follow the pointer in memory to item number 2, follow the point in memory to item number 3. You have got all of these jumps around in memory just to get to the individual item. Now that doesn't matter in a list of size 3. That matters a lot in a list of size 10,000. In a normal array, if I've got an array that has 10,000 items in it, which is not unreasonable at all when you're dealing with like machine learning stuff, you've got massive arrays and matrices and different things like that. If I wanted to jump to item number 10,000, I would start at the base address, multiply the size of the item by 10,000, and I'd get there. And add that to the base address, and I would get there. Here, I would have to traverse 10,000 different jumps in memory in order to get to the 10,000th item within a list. That's insane. That is an insane way to implement arrays. I am sure that there are brilliant people who designed Python and decided that that's the way that it needs to be, but you literally have to use NumPy in order to get reasonable arrays within Python, in order to get arrays that work as contiguous memory blocks and actually work as fast as they need to. That's insane to me. But that was a huge revelation. I did not realize that until I started reading this book. Honestly, that individual piece of information was worth the like $30 I paid for the book, because that was just absolutely insane to think about. I gave a more intelligent breakdown of why this matters in the blog, so you can go and read that. Okay, this one isn't going to be super long. I'm going to go through kind of my tactical plan going forward. kind of skipping ahead, I've already done another study session where I've started watching Karpathy, I believe is how you pronounce his name, Andre Karpathy. He's kind of like the go-to guy if you want to learn about machine learning. I'm going to save my rant about him and how amazing his content is for the next study session, but he's going to be one of the ones that I lean on the most. I'm going to work my way through the book because it is a really good book, and it does kind of give a breakdown of things from like the higher level, but Karpathy literally explains how to create a neural net from scratch, like in one video. It's like a 2-hour long video, and it's fantastic. So he's going to be one of the people that I lean on the most. I'm going to read the rest of this book. I'm going to actually learn linear algebra. That's going to be probably what I focus on this weekend a little bit. But yeah, that's kind of going to be what these study sessions are about. They're going to be rants. They're not going to be super polished. I'm literally not even going to edit this at all. But yeah, that's about it. Go learn AI. Take it easy. Peace.